Good afternoon. This is our video lesson for Earth history, Chapter 11, which is late Paleozoic Earth history. Just so you know, I'm filming this right after filming Chapter 10. I could squeeze all the notes for these two chapters on the boards at one time. So for me, this is following up closely on Chapter 10. For you, maybe it's been a few days since you looked at the last video lesson. That is okay. Okay, so from the late Mississippian, 326 million, to early Permian, 271 million years ago, we had major glacial/interglacial episodes over Gondwana, meaning glacial maximums followed by glacial minimums. We had these several of these episodes over Gondwana as it continued to move over the South Pole. So Middle Devonian to late Mississippian, we had our third of those 6 transgressions upon the North American continent. This one was referred to as the Kaskaskia sequence. So you'll see a map of this in either your textbook or in the PowerPoint slides. I don't think any of the transgressions, I don't think any of these later transgressions covered as much of the continent as the first two did. The Sauk sequence covered a lot of the continent, as did the Tippecanoe sequence. So, by the end of the Permian, 251 million years ago, we had Pangaea fully formed, our most recent supercontinent. And of course, that means Panthalassa was there as well, which remember was our giant one-world ocean during the time of Pangaea. So another little snippet here from the end of the Paleozoic. So into the Paleozoic, 251 million years ago, Pangaea is now fully assembled. We actually had arid and semi-arid conditions over much of Pangaea. Okay, why is that? So it's actually not good for our climate to have all the continents together. Okay, it's just as well that modern humans were not evolving at that time, because we would have had this one ginormous continent, this one ginormous ocean, and our conditions would have been not quite so sustainable for the amount of humans that we have on the planet now, we'll put it that way. All right, scooting over and always trying to adjust for glare. Okay, now we're looking at the middle of the board here. So, in the Devonian, roughly 416 to 359 million years ago, we had the Acadian orogeny. Remember, this is our second orogeny, or mountain building event, for the Appalachian Mobile Belt. And this is in the Devonian, and this takes place along eastern Laurasia. So, here again, this weird Iapetus Ocean is going to sneak into our notes. So the Iapetus Ocean is famous among geologists. It's this ocean that used to exist before Pangaea assembled. Basically, the assemblage of Pangaea killed the Iapetus Ocean. So at this point, the North Iapetus Ocean was already pretty much consumed, as we had during the Taconic orogeny. Well, here in the Acadian orogeny, second orogeny for the Appalachians, the South Iapetus Ocean is going to narrow between Laurasia and Gondwana. So you can imagine, as Laurasia and Gondwana are going to collide and form Pangaea, we're pretty much going to gobble up all of the Iapetus Ocean. Okay, so how about that third orogeny, or third mountain building event for the Appalachian Mobile Belt, known as the Alleghenian orogeny? This happened in the Pennsylvanian and Permian, or spanning 320 to 299 million years ago. And remember, it is the final orogeny, final mountain building event in the Appalachians, as you have Laurasia and Gondwana colliding to form Pangaea. We're getting ready to have Pangaea fully formed. Wouldn't be fully formed till about 250 million years ago. Okay. Adjusting for light glare. So this is our last bit of notes for Chapter 11. Chapter 11, really short. Okay, so a couple of things here that really are more intended for those of you that are in Dr. Farley's Earth History Lab on Wednesday afternoons. So cyclothems. These are repeating marine and non-marine delta sequences that you will find in each of your transgression regression cycles. Okay, now I'm not going to have anything regarding deltas on our exam in the lecture portion of the class. But those of you, I think there's about 6 of you that are in Dr. Farley's lab, he is going to touch on cyclothems. See, he worked for Exxon for about 10 years, and cyclothems are important when you're looking for oil, because being able to recognize ancient deltas in the rock record is important in searching for oil, because basically marine basins or ancient ocean basins are the source rock for oil. And our last snippet here, during the Carboniferous, which includes the Mississippian and Pennsylvanian, so we're talking roughly 359 to 299 million years ago during the Carboniferous, and it's called the Carboniferous because you had coal swamps. Massive coal swamps that would form all these coal deposits that today we find in the Appalachian Mountains, in the western states, and Western Europe. That's it for Chapter 11, and I'm happy to say that the video lessons for Chapter 12 through 19 I did last spring when the pandemic started. So after this, I'll be narrating PowerPoints. Peace out.